Welcome to Proposition 14 from Book 2. This is, of course, construction test number 3, and in this video I'll be walking you through that construction. So, if you have not yet taken construction test 3, don't watch this video. Wait until you've actually done the construction test, and then you can use this video to check your work and make sure that you've done the construction correctly. Let's take a look at what we're doing. So, of course, in Proposition 14 here, we have a given rectilineal figure, which is labeled A right here, and we have to construct a square with the same area as this irregular figure. And this is going to employ a number of steps, and this is going to be a really messy diagram. There is a simpler way, or I should say a neater way of doing it, but in this video I'll just show you the most straightforward way, even though it's not necessarily the simplest or the neatest way to do it. So to begin, we need to, of course, think about the angle in which we're going to construct this figure, because if you look at the construction and the proof, you'll see that Euclid immediately employs Proposition 45 from Book 1. And so we need to know the angle in which we're going to be constructing these parallelograms. And the angle, of course, is a right angle because we want to end up with a square. So what I'm going to do is I'm going to begin by copying some things here. And I'm going to be copying some triangles, of course. But to do that, I'm first going to divide this figure into two triangles so that I have a place here to begin. All right, so the first thing we're going to do is let's actually use, let's use this as our base. So I'm going to copy this there, and I'm just going to place it here, like so. So there we have this side. Now I'm going to take another line, and I'm just going to produce a line here in both directions to serve as the base. So this then is this segment there. Now that I've done that, I can go on to copy the other sides. So next we're going to have, let's do this in a different color to make it stand out. Let's do red. I'm going to copy this side here, and of course that's going to go there, and then I need one more circle for the remaining side here. So we've copied the triangle on the right-hand side. That's what we've done. And of course, we're looking for where the red and the blue circles intersect. That's going to be our next point. And it is, of course, right there. So now I can join all this like so. Now I've got my first triangle copied. Now what we have to do here is, because we're doing Proposition 45, remember 45 employs 44, which in turn employs 42. So I need now to take this figure and produce a parallelogram in a right angle. So I need to find a perpendicular line here in a minute, but in a right angle equal to this green triangle. And I'm going to throw some of these circles into the background and whatnot before I proceed, just to keep the diagram a little bit easier to read. And then we'll go on to produce the parallel line and the parallelogram. So to produce the parallel line, which is what I'm going to do first, of course, is a very simple thing. We simply copy the triangle about itself. I'll copy it about this side, so this point, the corresponding point, will fall somewhere over here. And so I'm simply going to copy the base here, and I'll place it there. And then I'll copy this side next and place the center there. You'll notice we have two circles which are very similar, so I have to be very careful in selecting this point. So I'm going to zoom in. Let's zoom in a bit here to make sure that I actually select the correct point. So the point we're looking for is where these two brown circles intersect, and it should be that one there. So now I should be able to join these two, and that should now be my parallel line. The next step, of course, is to bisect the base so that we can get our perpendicular. And I'll go ahead and do that now. And of course, this is also a very easy thing. We're used to bisecting things. And of course, the reason that this works, the diagrams here, of course, you can use to bisect the base, but it's also going to give us the perpendicular at the same time, as we know. So we can really kill two birds with one stone, like so. So this is going to be the perpendicular line, and it's also bisecting the base. So I'll place my bisecting point there. Now I have to zoom in again to make sure that I select the correct point up here, because it looks like the top of the triangle is nearly on this point, but it's not really the same point. So I'm going to zoom in. That's the beauty of computers. We can be really precise by doing things like zooming in, which of course is completely impossible on paper. But there, at least now I have my point, and it's clear which point that is. It's the one right there. Okay, so this then is going to be one of the points, or the corner rather, of my of my parallelogram. And so to complete the parallelogram, I just need to have a line, this length here, the length of the base of this side going here, and of course I can cut that off using a circle. So copy this length and then place it with the correct center, like so. And now this is the right length. And of course, this means that I've completed my first parallelogram. Again, I'm going to put some of these circles in the background just to keep the main diagram clear. I'm also going to put this triangle in the background as well, just so that we can focus on the parallelogram. Okay, so here we have our parallelogram, and so we've finished the step, which is proposition 42. Now, if you remember, this is still toward the beginning here of what we're doing, because we've taken care of this triangle, but we still need to take care of this other triangle, and we need to put the areas together in such a way as to make one large parallelogram. So we have one parallelogram here, and we have to find a way to attach a parallelogram equal to this area to this other one. And so the way that we're going to do that is by employing proposition 44. So this right here is going to be the line that I'm starting with, and I will even extend this out like so. And you'll see where I'm going with this in a moment. So I'm going to copy this triangle right on top of this line. So the triangle is going to fall up here. And the idea is that we're going to perform 42 on top of here. So we'll produce another parallelogram up here equal to this triangle. But then as we complete the diagram for 44, this will produce a complementary parallelogram down here equal in area to the parallelogram up here. So we will transpose a parallelogram equal in area to this triangle down here, and it will automatically be attached to this parallelogram that we've already produced. So that's what we're going to do. So of course, copying the triangle is a simple business. I'm going to use this as the base here. So I'll start with that length, choose this as my center. So now this is the base, and now I'm going to get this side there. And that will go, of course, I've got to zoom in to make sure I get the right intersection. We don't want to get the wrong intersection here. It's going to be that one. All right. And then we have one more circle, which is the remaining side there. It's going to share the center with the other one. So now what we're looking for, of course, is Here we have this base, and we're looking for where the two other circles intersect, because this inner circle was just giving me the base here. So there we have our triangle copied. So now that we have that, of course, we have to produce the parallel line, which a couple different ways of doing this. One would be to simply produce a perpendicular to this line. That would work, or we can actually copy the triangle about itself. That's what I'm going to do. So I'm going to choose this side to copy it around itself there. So I'm going to copy the base there and place that, of course, there. Next, I'm going to copy this side and place that there. And again, I have to be careful with my intersections. So we're going to zoom in again, just to make sure that we don't get this wrong. So there's my intersection there, and the other one there. So now I have my parallel line, which is in turn, of course, perpendicular to this vertical line. So now that we've gotten this far, we need to, of course, bisect the base and then complete the parallelogram. This will be easy, of course, because when we bisect, we will get a line at right angles, which is the angle that we're looking for. And so all we'll have to do then is see where that line takes us, and we'll have completed our parallelogram. So to bisect here, we'll do it like this. And now to join those points, all right, so having done that, we see that this here is going to be the point we're interested in, and the point down there, and then this will be our parallelogram. So I'm going to select those 2 points just so that we can be sure of them. And then we'll move on to the rest of this construction. So there's my point there, and then here is my other point there. So just to make sure that we know what we're doing, I'm going to outline this again in red just a little bit stronger so that we can see what we're dealing with. Okay, so there's the parallelogram that we've just constructed. Okay, so here we have this. So we've got our red triangle there, it's in the background, our green triangle here, and we have parallelograms equal to each of these areas. So we have a parallelogram equal to the green triangle down here, and a parallelogram equal to the red triangle up here. And so now what we're looking to do is complete the figure for proposition 44. We now have to draw our diagonal so that we can then use that to produce the complement over on this side, equal in area to this parallelogram. Now this is where it can get a little bit confusing. We have to be careful not to select the wrong corner. It's not this corner that we're going to use to draw the diagonal, because you'll see there's an overlap here. This is not actually within the figure. You'll remember from proposition 44, we take the point produced by this line here, there. That's the point that we're looking for, and we can now draw the diagonal like so, and then from this point we can drop our line down to there, and then we'll complete the figure, and we'll have our complement equal in area to our original triangle there. And then we will have produced, of course, a complete parallelogram. So let's do that. Easiest way to do this is, of course, going to be to use a circle. So let's go ahead and use our circle for that purpose. I'm going to zoom in to make sure I get the points right. Okay, so we're looking for radius there, and I'm going to place it right there. So this is what we're looking for right there. So here now is that, and I'm actually going to continue this down because we want to see where it's going to intersect below. So continuing to move down, we see now this is the point that we're interested in because this now gives us the dimensions of a parallelogram equal in area to this parallelogram, but this parallelogram, of course, was equal in area to this triangle. And so now we have our original parallelogram here from the green triangle plus this other parallelogram equal in area to the red triangle, which we had up there. So now, if we outline this again, you can see that we have produced a complete parallelogram, or I should say a larger parallelogram, equal in area to both triangles. And so this parallelogram is now equal in area to figure A. Because, of course, we have this parallelogram here equal to this triangle, and then the other parallelogram on this side equal in area to this triangle. That was the hard part, and you can see how many circles and lines we've got underneath this figure, but that was the hard part. Next comes something which is easier. So to make sure that it's easier, I'm going to hide some of the stuff that we don't need, throw it into the background and whatnot, and then we'll pick up with the next step, which is going to be to produce our point F, to produce BE to F. And so this will be BE, and then F will be somewhere out here, because this is now our parallelogram B, C, D, E, if you're looking at your book. Okay, so of course, if this black parallelogram is a square, then we're done. And that's as far as we need to go. But it's not. That should be pretty obvious from what we've done. And chances are it's not going to be a square. That would be pretty remarkable. And so then Euclid says, but if this is not already a square, then one of the sides is going to be greater. We're going to let this top side be greater, which it just so happens to be, so that's great. And we're going to produce it to F, and EF is going to be equal to ED, which is this side here. So we're going to produce this, so it'll be the same length as this side, which of course requires yet another circle. So that's easy. Produce a circle there. Now we have this point there. So now we have EF there. And we're going to also now bisect BF at G. So this now is BF. So this line from there to there is BF. So that's going to require, again, 2 more circles, of course. And we're going to bisect this like so. So this then, that point right there, which I can't seem to grab, is going to be, or is rather, our bisection. So that is G, that corresponds to G in the figure there. I'm also going to darken this a bit so you can see that this is part of the final figure. Okay, so far what we've done is we have our parallelogram here, and then we've produced this line, and we've bisected this side right there. The next step, which really is just about the final one, is to produce a semicircle. I don't have the capability of easily producing a semicircle with the software, so I'm just going to produce a circle, and we'll only think about the top part of the circle. So we do that like so, using that midpoint there. And so now I have this top part of the circle and my parallelogram attached to it. And then finally, we take this side here and we extend it all the way to the top of the circle. which I'll need to zoom in to make sure that I grab the correct point again. We can never be too careful. There it is. And I'll attach it there. And then this line there is line HE. And if you really wanted to complete the diagram, then we could then attach this to point G so that it looks more like the diagram in the book. But that's it. We are really done at that point. Because really the whole point of it was to generate line HE, which is this line right there. And having done that, we are completely done with this construction. Okay, so maybe this helps in terms of showing you how this is the same thing as what's in the book. You can see here that we have our parallelogram equal to our given rectilineal figure. We have our line there, which is equal to the side of the square, equal to this parallelogram. And then we have the semicircle that we've drawn on there. And I've just noticed that despite all my care, I seem to have somehow misplaced a point somewhere, because these two should line up, I believe. And somehow they don't. So I don't know. I'm not sure what happened there. Oh well, but that's okay. You can see at least that this is, yet again, a lesson in why we need to be so careful. So I hope that this has been helpful in showing you the process that this particular construction requires. I hope that this has demystified it a little bit. It is a very long one to do. This is why this is a construction test. Because if you can do this, you can do just about anything. It requires you to hold a lot of different things and a lot of steps in your mind all at the same time. You have to pretty much have a complete roadmap of the entire proposition in order to be able to get this right without constantly referring back to Euclid. So I hope that that was helpful, and now that you've successfully done that, let's move on to Book 3.